Hello everyone, my name is Rafael. I am an electrical engineer, and in this video I would like to invite you to see the solution of an exercise addressing symmetrical components applied to unbalanced electrical power systems. I'm going to read the exercise and show you step by step the solution. Let's go! In an unbalanced three-phase power system, the measured phase current of conductor A is 1 phase minus 90 degrees per unit. If the negative sequence current of conductor B is 4 phase minus 150 degrees per unit, and the zero sequence current of conductor C is 3 phase 90 degrees per unit, determine the currents in all cables A, B, and C and their symmetrical components. Okay, my friends, this is the exercise. I am going to show you the solution now, step by step. Okay, we already know these values here. IA, IB2, and IC0. Okay, and as the zero sequence components are equal, we can infer that IA0 is equal to IB0, which is equal to IC0, which is equal to 3 phase 90 degrees per unit. Okay, this we already know. Else, for the negative sequence IB2, then the negative sequence current IB2 leads IA2. Okay, the negative sequence of conductor B leads the negative sequence of conductor A. And by knowing this, we can do the following. IA2 is equal to IB2 over alpha, where alpha is equal to 1 phase 120 degrees, okay? Using this factor, the factor alpha, we can calculate that the negative sequence in cable A is going to be 4 phase minus 150 degrees. Okay, this one divided by this one here. 1 phase 120 degrees, which is equal to 4 in the phase 90 degrees per unit. Alright, with these values we can calculate the positive sequence component of conductor 1, conductor A, okay? We have this, and we have this. We can calculate the positive sequence of conductor A, which is gonna be, since IA is equal to IA1 of positive sequence plus IA2 of negative sequence plus IA0 of zero sequence, using this, okay, this value here, this is what we want to find. This is this and this is this. We can calculate IA1, which is going to be equal to 1 phase minus 90 degrees, which is this, minus 4 phase 90 degrees, which is this, minus 3 phase 90 degrees, which is this. And the result is 8 phase minus 90 degrees per unit. Okay? Likewise, we can do for conductor B, all right? And IB1 is gonna be alpha squared times IA1, okay? IA1 we calculated. This is squared, okay? And this is gonna be one phase minus 120 degrees multiplying this value here, 8 phase minus 90 degrees, which is equal to 8 phase 150 degrees per unit. All right, we know the positive sequence current of conductor B. We have the negative sequence current of conductor B. And we have already the zero sequence current of conductor B. We can use these values to calculate IB. IB is going to be equal to 8 phase 150 degrees plus 4 minus 150 degrees plus 3 phase 90 degrees. Okay, this is this, this is this, and this is this, and we find for conductor B a measured value of 11.53 in the phase 154 degrees per unit. All right, this is the current that passes along conductor B. This is the current that passes along conductor A, and we can do the same for conductor C. Similarly, for conductor C, IC1 is going to be alpha I A1, which is equal to, okay, IC1 leads by 120 degrees, IA1. And then we find the value of 8 phase 30 degrees per unit. And for the negative sequence current, we find alpha squared IA2, okay? IC2 lags IA2 by 120 degrees, and we find the value of 4 phase minus 30 degrees per unit. With these values, we can calculate the current along conductor A, which is equal to IC equal to IC of positive sequence plus IC of negative sequence plus IC of zero sequence, which is 11.53 phase 25.7 degrees per unit. All right, these are all the components of A, of B, and of C. And this is what I wanted you to see. Remember that this holds for them all, okay? This holds true for conductor A. The measured current is the addition of the positive sequence, the negative sequence, and the zero sequence. For IA, for IB as well. IB is equal to IB1 plus IB2 plus IC0, and IC the same. The measured current is equal to the sum of the positive sequence component plus the negative sequence component plus the zero sequence component. Alright, my friends, this is the video that I wanted to make. I hope you guys learned from it and enjoyed a lot of the video. I am a teacher, and if you want to book a lesson with me, use my WhatsApp number, guys. Goodbye!